All right, this is lesson 4 complex numbers, day 1. So we're going to perform operations with complex numbers. So this first day, we're just going to talk about simplifying radicals and then what an imaginary number is, and then do a couple of examples of just simplifying and solving. And we will do the adding and subtracting and multiplying of these various things on day 2. So let's just talk about simplifying radicals. This should be a review, but I know it's been a while. So we want to think about those perfect squares. So keep those in mind. The 1, 4, 9, 16, 25, 36, 49, 64, and so on and so forth. As many as you can get up to, preferably up to 12, which would be 144. Okay, so we want to think about the factors of 75, and we want one of them to be a perfect square. So what could I divide 75 by? And hopefully you are thinking 25. So 25 times 3. So we're just going to split this up still under the radical as our two factors. So 75 is the same thing as 25 times 3, and they're both still under radicals. Next, we look to see which one's our perfect square, and we can actually undo, because the square root of 25 is 5. So it's no longer under the radical when we bring it out and do the square root of 25. However, this stays under, and it comes down next to it, and we are done simplifying. So 45, look at your perfect squares, or think about those perfect squares. What are the factors of 45? One of them being a perfect square. Hopefully you were thinking 9 and 5, and we leave the 7, it comes along for the ride. The square root of 9 becomes a 3 out front, and what we do with those numbers is we multiply them together. When it moves out front, it's multiplication that takes place because that's what's already out here, is these two are being multiplied. So this is multiplication. So 7 times 3 is 21, and we leave that square root of 5 next to it because we cannot simplify that anymore. So 20. Think about, try this one on your own, very similar to number 2. Think about which one you could divide 20 by. Split it up as your perfect square times another number to get 20. Bring that -2 along for the ride. Simplify your perfect square and multiply it by the -2 out front. And so pause, try that one on your own, and then push play to check. Hopefully you got -2 times square root of 4 times square root 5, so it's -2 times 2 in front, so -4 square root 5 for your final answer. All right, the next one, when we have division, we're going to give the square root to the top and give the square root to the bottom unless we can simplify that fraction, which in this case, these are perfect squares, so we can just go ahead and give it to the top and the bottom and actually do the square root of 121, which is 11. So that's why memorizing those perfect squares is going to help you tremendously all the way up to 12. Square root of 144 is 12. So we're done. We don't have any square roots in the denominator spot, so we're as simplified as we can get. So it's okay to have a radical still in your answer. It just cannot ever be in the denominator spot. So here's our next one. Yes, we could give it to the top and give it to the bottom, but this fraction could be reduced. So that's what we want to go ahead and do first. So reduce that fraction is going to give you 16 over 24. We can divide both by 8. So that would wind up giving you 2 and giving you 3 with that negative still out front. So I just gave the radical to both, the numerator and the denominator, which is the same thing as the whole thing being under a radical. And then this next step, remember I told you you can't have a radical in the denominator spot. So we're going to go ahead and do what's called rationalizing the denominator, which means we multiply by the radical that's already down there. And we do that on the top and the bottom. It's like the same thing over the same thing. So really, you're just multiplying this whole thing times 1. It's not going to, not just pulling a number out of nowhere. Got to keep it balanced. And it's like this is 1. And so it's still kind of keeping its answer and keeping it equivalent, just simplifying it in a different way. So when we take radical 3 times radical 3, we would get radical 9. And when we take radical 2 times radical 3, we'd get radical 6, still have that negative out front. And then the last step, this is a perfect square, and that's the whole reason why we multiplied it by itself, is because it can simplify to no longer be a radical, and we have our simplified answer. So just cannot have a radical in the denominator spot. And then the last one here, you want to simplify your fraction vertically first if you can. So remember, numbers in front can simplify and radicals can simplify. So if we do that, we'd get negative 4. And then 24 over 2, we would simplify it still under the radical, and that would be 12. And then we reduce. So always think about, is that radical something that I could divide a perfect square by? And yes, 12 has factors of 4 and 3. And 4 is that perfect square that's a factor of 12, which we can then simplify to 2 and multiply it when it comes out front. And then we've got our final answer. So simplifying radicals, it's really important that you have a grasp of that concept before we get into our complex numbers. So next product, go ahead and multiply those two things together just like we did here. Multiply underneath the radical and then put it under one radical together and then simplify. So pause, try that. Basically, you're just simplifying the square root of 20. So you should have gotten 4 and 5. And the 4 becomes a 2 when you simplify it, and the 5 stays under. Now, when it comes to adding, you are going to, all right, you are going to add like it's like terms. So if this is square root of 17 and this is square root of 17, you can then just add how many you have. So here I have 3 square root 17s. Here I have 1 square root 17. So I have a total of 4 square root 17s. And I cannot reduce that square root of 17 since that's prime. And we are done. So you've got to make sure that you've simplified it first, those radicals, then add the like radicals. So here I can simplify the 8, I can simplify the 18. So we want to do that first. So let's go ahead. I have 4 and 2 that give me 8. I have 9 and 2 that give me 18. So I wind up with 5 times 2 because the square root of 4 is 2. And I leave the square root of 2 there. So all we did was simplify that square root of 4 and move it out front with the 5. And we multiply those two things together. And then here I have the square root of 9 that's going to move out front and become a 3. So 3 times 3, that would be a negative 9. And then the square root of 3, I'm going to go ahead and just bring it down. So now we can go ahead and combine these things together, add them all together. So since that negative 3, we already have that negative sign there. So we're just adding all these things together. So the only things we can really add together are those ones that have the like radicals, which are these first two. So again, we add how many we have. 10 minus 9. So that means I only have one of them. If you want to put the 1 out front, you can. You don't have to. It could just be square root 2 because we already know we've got one of them because it's right there. There's one of them. And then we have to bring down this plus radical 3 because I can't add these because they're two unlike things. And so that's all I've got for my final answer. So keeping those rules in mind when we come to these imaginary numbers. So what is an imaginary number? An imaginary number, we get this I, and the way we get the I is it's a square root of a negative number. The square root of negative 1 is I. And a lot of times we see it kind of with a little curl there versus straight up and down. So if I were to take I and square it, it's like we are taking and squaring the square root of negative 1, which ultimately just gets rid of that square root and we end up with negative 1. And then if we were to take and cube that, so square root of negative 1 cubed, it would wind up with moving one of the negatives out front, and we'll talk more about how that works. It'll be better once you see a couple of examples with real numbers. But just keeping these 4 in mind as we're working. Let's go ahead and talk about what a complex number is. So a complex number is when we actually have a real and an imaginary together. So it's written in the form of a plus bi. So the real part is this a, what's being added to the imaginary, a. Let's give you an example with some numbers. So 2 plus 3i. This would be considered a complex number. And the 2 is going to be our real part, so A or 2. And then our imaginary part is the B, any number in front of our I or connected with our I. In this case, it's the 3I. That's our imaginary part, what's with the I. So when we come down here to simplify, that negative is the part that comes out front and becomes the I. And then we just simplify the numbers kind of like we simplify the radicals there. So if we have a negative number under the radical, it's like a -1 times a number. So this part becomes the I out front, and then we just have the number under the radical that we then can simplify. So the negative kind of moves out front and becomes our I in a sense. So let's go ahead and just split this up so that we can kind of see its parts. So I'm going to keep that as -1 and I'm going to keep that as 121. Kind of separate the negative from the number. So this part becomes I, because the square root of -1, we already talked about that up here, square root of -1 is I. The 5 stays out front. Next, we want to simplify the 121, which the square root of that, since it's a perfect square, is 11. Now, when we move it out front with the 5, remember we multiply. So 5 times 11, we can go ahead and multiply those, and it's 55I. And that is our final answer. So on this next one, the negative again is going to move out front and it's going to become an I. So it's like negative square root -1, square root 96. So this is the part that becomes the I out front with the negative. Then we simplify the 96. So the 96 we can simplify as 16 times 6. Again, try and think of perfect squares that are factors. 16 becomes a 4 out front with the negative I, and we're going to rewrite this. And then the square root of 6 is going to stay under. This is a times sign. So we move the 4 in front. We always want to have the number in front of the I, just kind of like it's written here. So -4I square root 6. So split it up into parts. The only difference of this versus our simplifying on the front page is that this negative is becoming the I out front. So that's going to become an I, the negative, and now we just have the 12 that we are simplifying. So it's 4 and 3. The 4 becomes a 2 out front. The 3 stays under, and the I is out front with the 2, and it goes behind the 2. So the I is never in front. It's always behind the number. Try D on your own. Pause the video. Make sure that negative comes out front to become an I, and then simplify your number, your radical. So you should have gotten 2. The negative moves out to become the I. The square root of 36 is 6, which then ends up multiplying times the 2 to get you 12I. All right, let's go ahead and talk about solving. So when we go to solve, we end up, when we do the square root, we're going to have 2 answers. And here's kind of that explanation. When we do the square root, we could have a positive square root of c there, or we could have a negative square root of c. So here's a couple different examples. When we take the square root on both sides of 25, well, we could have, when we plug 5 in, a positive 5, or if we plug -5 in and square it, we'd end up with a 25. So that's why we kind of have both the positive and the negative answers for our solutions. So when you take the square root of both sides, make sure you do plus and minus as a part of your answers. So square root on both sides. Then make sure you have plus minus in answer. All right, going to work a couple of these examples here, and then this is going to feed into a part 2 video, so make sure that you watch that part 2 to finish up this lesson. Square root on both sides here. So that ends up giving us x equals, remember, plus minus. The negative becomes an I out front, and the square root of 124 is 12. So make sure that I goes behind the 12. Square root here, so x is equal to plus minus. Square root of 36 is 6. The negative becomes an I. So make sure to watch the next video to get the rest of this lesson.